Of 4.1 and just want to go through these important things to be able to identify them from a statement to see if we can identify a population, parameter of interest, sampling frame, sample, sampling method, whether or not you felt it was randomized, sources of bias, including direction of the bias, and any variables that could be lurking or confounding the results. So some of these things won't be present in these things that we're going to read, but we'll just go through and see what we can find. So this is Consumer Union, and they're asking all their subscribers whether they had used alternative medical treatments, and if so, whether they had benefited from them. So what are they probably trying to describe? Their population? I think they are trying to describe probably all U.S. adults. And they're trying to use their magazine subscribers to do that. And so the parameter that they're trying to describe about these US results would probably be a P for proportion. That's the proportion of people who benefit from alternative medicine. Okay, so that's what they're probably trying to do. And so then that's going to come up with a percent because they're asking people categorical data like whether or not they benefited, yes or no. So their frame, though, their sampling frame, is the people who are available for them to ask. And so that is basically all the Consumer Union subscribers. Those are the people who are actually available for them to ask. And what did they do? They sent it out, and their sample are the people who responded. So this is when you have the option of responding or not responding, that we have to decide, is that voluntary response bias or is that non-response bias? And Consumer Union did ask these people, so that means that the people who did not respond to being asked are going to have non-response bias. So, okay, so that's going to be, we're going to have non-response bias. Because some people won't answer. And so who did answer? Only people who feel strongly, who care about alternative treatments will reply. Since people who care about alt med will be expected to reply. The sample statistic, right? Statistic being the sample value, which is P, and actually we put a hat on it to show that it's a sample value. The P hat of 0.20, what do you think that means? I think it means that it's over-predicted the number of people who like alternative medicine, because the people who like alternative medicine probably are more likely to care and are going to reply. So I think that P hat of 0.20 overestimates the true proportion. of people who like alternative medical treatments. This sample, because they're sending it out there to their subscribers, you probably could have used the word convenience. Convenience. Okay, convenience, because that was convenient to them to send it out to them. That is another idea that you're going to be having bias. And but I would say that non-response was the bias that was prevalent here, because we asked them, but not everybody answered. So what was different about the people who would not answer? And what might be a lurking variable about consumer union subscribers? If you have enough money to subscribe to a magazine, I would say that there could be a lurking variable of that these people have maybe of money and being more educated because they want to read a magazine. So those might be some lurking variables. And I wonder, is having more money going to help you do more alternative medicine? That seems reasonable. That would be another way that a lurking variable, when you have a lurking variable, you want to say how it corresponds to the variable of interest. Having more money would make having more alternative treatments more likely. So having more money would correspond to positive correlation to having more alternative, or positive association to having more alternative treatments. And then being educated, maybe being more educated means that you know more about medical things, maybe less so than the money, but like maybe having more education also has a positive association with having more alternative medical treatments. So watch for the lurking variable. Make sure you say how they correspond. Okay, this next one, we're going to wait outside a bar. It looks like we had a sampling frame, which was a list of all such establishments. So we had a list of bars, and we randomly selected a bar. Now we're going to stop every 10th person who comes out of that bar and ask them whether or not they think drinking and driving was a serious problem. So we are trying to, our population, I guess, what is our population? Is it all US adults? All adults? Or is it all adults who go to bars? We would have to know, what are we trying to decide? It looks like we are trying to find for a parameter, which is P, not with the hat. If it's a parameter, no hat on it, will be the proportion of people, of adults who think drinking and driving is a problem. So our frame is going to be the patrons at the randomly selected establishment. All patrons at the randomly selected establishment. And I'd say that our method was systematic, in that we were going every 10th person who came out. So we were systematic. Now we have to, and in a way, each of these establishments, each one was a cluster. So I could have gone and sampled each person at that establishment. That might have been a better way to get at the cluster. But, you know, I guess it depends on what you're trying to describe for a population. If you're trying to describe all adults, then I can see a serious source of bias in this situation, that because we are going to a bar, because we are sampling outside a bar, what do you think is going to happen? I think p hat, whatever number we get, they didn't tell us what the number was, p hat will underestimate, because I think we're going to get less people saying that drinking is a problem, the true p value, that true p, which is the proportion of people who think drinking and driving is a problem. Okay. So you're looking for bias when you're looking through these things, thinking about what you're trying to describe, thinking about how they're doing the sampling. So in this one, we have the Environmental Protection Agency taking soil samples at 16 locations at a former industrial waste dump, and then they're checking for evidence of toxic chemicals. They found no elevated levels of harmful substances. In this case, if they're going for concentrations, I would say that's probably more of a means problem. So the mean would be the true mean toxic chemical level for all the soil in the site. But we're going out there and we're getting the mean. Our statistic is going to be the mean toxic chemical level at 16 locations. Our frame, our sampling frame, will be all accessible, because some of the sites might not be accessible around the site. But I don't know if I can really say if there's any bias here, because it's unclear how the 16 locations were selected. So I'm not going to report on any bias, because right now I have really no clear reason for this bias. Okay, so this company is going out and packaged food snacks. They're trying to maintain quality control by selecting 10 cases of their food snacks. They'll pick the whole case, and then they're going to take the bag from each case and inspect the contents. So this, to me, if they've got all their cases and they've labeled all the cases, so, and each case has the same chance of being selected, then what I see them doing right here is a simple random sample. And what they're trying to describe here is a population of all the chips, right? Are these chips? Snack foods. All snack foods. And then but they're going to have a sample that's going to be the 10 selected cases. So the smallest unit that our sampling unit in this case is a case. That's the smallest amount that you're going to select. And then you're going to then take that case and weigh the production contents inside that case. I don't see any violations of the randomness. If somebody goes out and does a simple random sample, they've labeled each case, they've selected 10 cases randomly, then I don't see any violations of randomness. And so it seems reasonable to say that this is a random process, and I don't see any bias if it was done randomly as it's being described. Seems like it'd be reasonable. Okay. So just some examples of like what things can go wrong. There's sampling error, and then there's non-sampling error. And by far the worst is non-sampling error, because it's kind of an error with sort of your whole collection and design of the whole thing. So when you have bias, you do have to make sure that you report the direction of bias. How is the method that you're using consistently overestimating or underestimating? Sampling errors that you may see would be something like a random sampling error, like maybe the machine you're using is reading people's blood pressure, but always reporting it 10 points lower than it's supposed to be. Or you have a thermometer and you're trying to take everybody's temperature, but this thermometer is always reporting, half a degree lower on each person. That would be that your statistic is off by some specific amount that just keeps happening over and over again. That's a random sampling error. Or like maybe people coming in from outside, their temperatures might be lower because they came in from outside on a winter day, but this person came from a car that was warm and this person walked across a parking lot. So that's random sampling error, things like that. Okay, then you have under coverage. That's when subjects are going to be left out of the sampling frame. For example, if they're trying to say that they are coming up with a COVID vaccine, well, leaving women and leaving people who of other ethnicities out of the sampling frame is under coverage, and it is going to not allow you to see how women or minorities might react to this vaccine. The vaccine will only be valid for the sampling frame that was actually used. So we look for that. Then you have your problematic sampling methods that we look for, the bias and convenience sampling being one of them. So make sure you look for bias here. Voluntary response or self-selected samples, so like, why are they coming forward? And then you have your non-sampling errors, which I would say these are definitely the worst ones. Response being the first one to talk about, and that's when, for whatever reason, that group refuses to answer. So it makes me think of the polls with Trump and Hillary Clinton. All the polls were saying that Hillary Clinton was going to win, but then in the end, she ended up losing, in the Electoral College. But part of this was because, or part of the surprise was because of the non-response. And so some people tended not to answer, but then they tended to support Trump. So that meant that we had bias that underestimated the support for Trump because of the non-response of the people. So people have refused to answer, or maybe they're incapable of answering. Like maybe you've asked this thing in a way that's not going to allow them to be able to actually give you an answer. Then there's response bias, and that's when they might lie or they tell you what they think you want to hear. And like, for example, with NPR, there was a survey of church attendance in America, and they found that Americans would actually lie and say that they were going to church on Sundays. And so they were systematically over predicting the proportion of people who went to church on Sundays. And this was really interesting because then they went to Europe and they looked at people in Europe, and people in Europe, their church attendance actually matched what their responses were. They didn't have the same response bias in Europe because maybe in America, people felt like they needed to say they went to church, and that's why it over predicted the church attendance. And then you could have the wording of your questions might influence someone, like maybe using words that incite strong feelings. Maybe like having the order of the answers. Actually, like Joe Biden having his last name with B is higher than Trump on the ballot, and that actually is considered to be an advantage. And that's why Amazon picked their company name to be starting with the letter A, was because he wanted to be in the order of answers. He wanted, Musk wanted to be the at the top of the list. So, or choices. Wait, that's not Musk. That's Bezos. Bezos is the Amazon.